Hello Chem 1. Today in 2.7 we're going to take some topics we've talked about like Q equals MCAT equations and phase changes and combine them into one enthalpy equation. Enthalpy is the heat within a system. It's a measurement of how much heat that system can hold. Up until this point we've only dealt with Q equals MCAT equations. Q equals MCAT equations are good when you're dealing with a substance that is not changing phase. But when a substance changes phase, that takes energy, and therefore you have to calculate it as part of the total energy within a system. So we will only ever do these with water. You can do them with any substance, but water is kind of what you're going to be responsible for here. So in order to do a enthalpy change equation with water, you need to know how much energy it takes to boil water. You need to know how much energy it takes to freeze water and all of those phase changes so you can calculate it correctly. So if we look down here toward the bottom, we have something called the heat of fusion for water, which is 333 joules per gram. What does that mean? That means that if we're going from a solid to a liquid or a liquid to a solid, it's going to take 333 joules for every gram of water we have. Notice that if we're going from liquid to a solid, the H of F becomes negative. Why? Because we're losing heat. That was an exothermic process. And therefore, we just make the 333 negative. Just to be clear, that 333 applies to that phase change right there, the melting and or freezing. But there's another phase change, which is the heat of vaporization. We know we also have condensation and vaporization. Well, the heat of vaporization is the number that would apply to that phase change, 2,260 joules per gram. Notice there's a lot more heat required here. So if we're going from a liquid to a gas, it would be positive 2,260. And if we're going from a gas to a liquid, it'd be negative 2,260. All right, let's try an example problem. The key here is you have to remember that you have to use the correct equation based on what's happening during the process. This is a multiple step math problem. So let's look at what we got here. What energy is involved when 20 grams of ice is heated from negative 7 degrees Celsius to 0, then melted and heated to 25? So if we use our diagram over here, the first step is to go from negative 7 degrees up to 0. This is when the phase change is going to occur. Then step 2 is the actual phase change, and step 3 is going from 0 up to 25. So there are 3 steps in this equation. So as long as we're within the same phase, we just use Q equals MCAT. So Q equals the mass, which is 20 grams of ice. So now we need the specific heat of ice. And if you look on your equation sheet, you will see that it is 2.077. And then we need the temperature change. Well, we're going from negative 7 to 0. That's a positive 7 degree change. So then if we solved that out, it would give us the amount of heat to go from negative 7 to 0. The next thing we need to calculate is the phase change. The phase change is simply calculated by the heat. So we need to know how much energy is required to take this 20 grams and basically melt it. Well, we need to use the heat of fusion, and that would be 333. So for every gram of what we have, it's going to take 333 joules of energy. So we just multiply them together. And that would give us the Q for the phase change. And then finally, we would take Q, and we need to go from 0 to 25. So we still have 20 grams of substance, but now, key here, it's water. So the specific heat has changed to 4.184, and we've gone 25 degrees up from 0 to 25, so a positive 25 degree change. So you can see how these equations are a little more, it's the same thing, but you have to be really organized and pay attention to, okay, when's my phase change occurring? What's happening? We will only ever do these with water. All right, I'll never give you a foreign substance to do these with, but you need to be able to identify, okay, this is a 3-step problem because we're going through a phase change. So if we look at our answer here broken down, based on how we set up the first equation, we get 291 joules. The second equation would be, which is our phase change, would be 6,660 joules. And our last part, which is going from 0 to 25, would be 2,092 joules. So what do we do when we want to know the total energy? You're going to add all those 3 steps together. You'd get 9,043, and then we would round to 9,040 joules. Why? This is an addition problem, and this number here has the least number of significance to the right, which is in the tens position, which means our answer needs numbers in the tens position. And that's how you do a 3-step phase change enthalpy problem. Let's take a look at another one. This says how much energy is involved when taking 50 grams of steam at 109 degrees Celsius and cooled down to 10 degrees Celsius. So notice it doesn't address the phase change, but the phase change is there. It's water, and you're going past 100. You're going from 109 down to 100. Then you're going to have your phase change at 100, and then you're going from 100 down to 90. That's the first change. The second change is that we're not dealing with ice or solid and liquid. We're dealing with gas and liquid, which means we're going to be using the heat of vaporization. That number is 2,290. And third, the third difference here is we are cooling down. What does that mean? It means that our temperature changes should be negative and our heat of vaporization should be negative because we are losing heat. Let's take a look at what this looks like. Here's our first step. Q equals MCAT. We're going from 109 down to 100 degrees. So that's a -9 degree change. And here is the specific heat for steam, because that's what phase we're in at that point. And we have 50 grams. And we calculate -919 joules. Step 2 is the phase change. We have 50 grams of substance. The temperature will still be 100, so we don't have to deal with a temperature change. But the heat of vaporization should be negative because it's cooling down. And you will see it takes a lot of energy for water vapor to go from gas to liquid. Finally, step 3. That's when we go from 100 all the way down to 10. So that's going to be a negative 90 degree change, which we see here. Notice that our specific heat is liquid water, 4.184. We'd multiply that together. Notice that all these numbers come out as negative. Why? Because we're losing heat. It's exothermically removing heat to the atmosphere. We'd add all those up, and we get negative 133,000 joules. The reason we stop at this position here is because this number here only has significance as far right as the thousands position. And so that's where our answer will have significance too. Those 3-step problems can be a little tricky. You definitely need to be paying attention to if a phase change is occurring, and it helps to really understand how the math mirrors what's going on in the real life experiment. Good job today. Keep working hard. We will see you soon.